Okay, we're talking about the turning of a compost pile today, or a set of compost piles. We have a large one here and adjacent a smaller one. As is normal, we both name our piles and then we track the temperature. In this instance, a lot of people made this pile. There were a lot of decisions to make. How much C, how much N, is this an even layer, how much water to put on. So I took the liberty of naming it Vox Populi, the people's voice, and the other one Lil, it's apostrophe L-I-L, Vox Populi. So I've tracked the temperature on the labels here. We started out on October the 15th. The temperature was, as it always is when you begin a compost pile, ambient 65 degrees. So we started here, and there was a discernible within 72 hours heat curve rise, and then about 7 days later we reached our peak, which was 132 degrees. Maintained that for a week or so, and now we're starting to drop down. So here's the heat curve. Ambient heat rise as bacterial waves of populations come in and decompose rapidly. Get to the top of the heat curve here, you're probably moving over to more fungal populations. Starts to drop off. Right now it's at 102. The question is to turn, or to paraphrase Hamlet, Shakespeare, or misparaphrase, to be or not to be, that is the question, whether it is more noble, with compost, to turn or not to turn, whether it is advised, To turn or not turn. You don't have to turn a compost pile. If you make it correctly, you made the cake, hey, let's let it bake. Just let it play out, go through its heat curve. Reasons to turn a compost pile. One, if you're an organic grower selling produce to the public, you need to have a certified product, and the rules and regs say you reach 131 degrees, you maintain that for 15 days, during which time you turn the pile 5 times. That's to use on fresh vegetables. And it proves to be impractical for the small grower or the even mid-sized farmer to do, so most farms will buy in a certified compost. There's a little bit of a legal workaround, which is that if you're applying the compost to aerial crops, zucchini, peppers, eggplant and such, crops that don't touch the ground, if you apply the compost 90 days before harvest, it's fine to use a uncertified compost. With crops that touch the ground, such as leaf crops and root crops, it's got to be 120 days. So you have different routes to go. So in this case, we're not actually trying to certify this compost. We have a bought-in compost we use on our vegetables that mandate it. But we're just trying to make a righteous compost here. So we have a pile. Started out, heat curve was, as mentioned, the pile was about this tall, and it's settled. And in the process of decomposition, the pile will settle maybe as much as 40–50%, and that's simply because the structure of the material, particularly the plant material, breaks down and the pile subsides. And also, when you get up to the heat curve and you're flat, and then temp starts to drop off, probably it's because oxygen is the most limiting factor. As the pile compresses upon itself, it squeezes out the air, and as the microbes use the air, more particularly the oxygen in the air, you become oxygen deficient, so things slow down. So a remedy is to turn the pile. When you turn a pile, and you turn it thoroughly and properly, you're re-aerating the pile, and it's not uncommon to get a boost in the heat curve. So the curve was ambient, peak, descending, turn, whoops, a little rise again, and you can do that once, twice, thrice. Turning a pile also breaks up the material further, making it more susceptible to further microbial decomposition. Turning a pile, in essence, quickens the time to maturation. Turning also can be a corrective. The pile's too wet, the pile's too dry, it has too much carbon, it doesn't have enough nitrogen. You can make some corrections, but be careful. It's too dry, we wet it. Whoops, pendulum swing. Now it's too wet, we have to dry it out. There's too much C, we put it in. Whoops, too much N, yada yada yada. So The other thing that I really like about turning a compost pile, let me just say my preference is to make a pile, let it sit, let the cake bake. You made a cake, let it bake, and make another pile, successfully going down the line. But in turning it, it's a great investigative tool. How did we do in putting the pile together? We were trying to alternate these layers of carbon and nitrogen. In this instance, we want about 2 or 3 times the thickness of the nitrogen layers to 1 time 1 inch carbon, 2-3 inches nitrogen. We want evenness, we want even wetting. Just the evenness principle applies all the way around to a compost pile. So let's do a little investigation. Maybe I can get Will to help me pull back the tarp here. I should say tarps.
There's a bunch of molds in it.
All right, it's always revelatory. Let's just take it easy. So we're creating habitat here for microbes and also for macrobes. That is a vole. A vole is kind of like is like a mouse, but a mouse that's like both diurnal and nocturnal, and on performance-enhancing drugs on the U.S. Olympic sprint team. This is all over the place like that. Okay. Back to the script. To cover a pile, to tarp a pile or not. You might, as we have at this time of year, fall, tarp a pile to insulate it. You might, as we have at this time of year, fall, with the advent of the rainy season, tarp it to keep it from getting more moist. A week, 10 days ago, we had a rain event over 72 hours. We got about 10 inches of rain. Yesterday, the night before, we got 1.4 inches. Tonight through tomorrow morning, we're going to have at least scattered showers. So we protected it, and in tarping it, you're also insulating it and getting greater heat. Let me just say, there's no right or wrong with temperature rise in a compost pile, but certainly in biochemical systems, and this is certainly a biochemical system, the warmer it is, the quicker reactions happen. So I want to turn this pile, and like I said, one aspect is to completely remix it and homogenize it. We have a nice cube form here. When we end up, we'll have a nice haystack form. But I'm just gonna pull a little bit out with a pull fork and see where we're at. There was an admixture of succulent greens that went into this pile, and there was straw, and there was chips, and there was leaves, and there was a horse manure mixed with bedding material. We are approximately 20 days in, and where are we at? Where we're at is I'm pretty pleased with the initial rate of decomposition. You see the off-gassing here. This is largely water vapor and hopefully not ammonia gas. Pleasant, not sulfur smelling. Presence of ammonia gas means too much nitrogen, it's anaerobic. You got a problem right here in River City. We got a problem, and so you turn it to re-aerate it and hopefully remedy it. But this is just water coming off from the water in the materials as CO2 water vapor. And again, we put in whole green lush plants. There's no, 20 days in, there's no visible remnant remains. Yeah, some of the more woody, sticky stuff is there and may even persist through the end product like that. I'm gonna give the folks that made this pile an A-. I'd give them an A+, but I don't want them to get a swelled head. That is, they put it together well with even repetitive layers, C, N, C, N. They put an adequate amount of moisture. I was concerned we didn't put enough moisture, but very apparently we did. We are moist. warm, wet, good. I'm starting to see here a little bit of microbial, mycelial stuff. If you look, you will see gray webby substances. These are the microbial remains of fungal organisms. They're hyphae, etc. If you look at my hand here and you look similarly down in the piles, I pulled more of the compost pile out. You see these white strands, mycelial strands, no doubt. Mycelial strands are the hyphae of fungi, and or indicating the presence of Actinomycites, a third type of organism along with bacteria and fungi that populate compost piles. Actinomycites are kind of halfway between bacteria and fungi. They're single-celled like bacteria, but they have hyphae like fungi, and they are voracious eaters of wood, carbon, lignin, chitin, etc. They really are finishers in terms of decomposition. So to cut to the quick, this is good. We got a good heat curve rise. We maintained it for a week, 10 days. It's starting to drop down. We're going to now turn this pile and re-aerate it, hopefully get a little heat surge. And again, in the process of turning and mixing and putting it back together, we should get an increased oxygen content in the pile. And then that should give rise to another microbial bloom. And it's like a relay race here. You have these different waves of organisms. Initially, you have bacteria, which are really good at decomposing the soft, succulent, nitrogenous material. That is why their populations are exponential, increase quickly. That is why, 20 days in, you see no remnants of green plant material, gone, dissolved. The nutrients that are in the material that's in the compost pile are absorbed and used by the microbes, and then as they die, they liberate it in the form of nutrients, nitrogen, phosphorus, potassium, magnesium, etc. So we're in pretty good shape here. And now I just want to turn it. Again, another factor is, how did we do at putting together the pile evenly? The answer is, you done good, folks. This is a well-constructed pile here. We're going to line up here 3 or 4 people, pull material out, make a new pile over here, and you need to do this in a pretty articulate and detailed manner, just kind of putting it together. If you see any undue dry pockets, or you see anything that's really coarse and not decomposed, put it aside, and then when you reconstruct the pile, put that coarser stuff back into the center. It'll help it to decompose. It's not rocket science, and yet it's not slipshod. You turn the pile and you're just really considering, how do I get the inside on the out and the outside on the in? So again, maybe we do something even a little more detailed. We take the outer 1 foot and put it over here. We take the next section and we put it here. We put the heart of it there. Again, noting anything that's really non-conforming, I'm going to say, and we try to put that back into the center. So you take the top off, you put it here, you take the middle off, you put it here, you take the inners off, put it here, and then you put the inside out on the way back. Put the least decomposed exterior stuff in the core, the more decomposed. So among the other factors that you're considering when you're deconstructing and reconstructing a pile, as I said, you take the outer section and put it over here, the middle section put it here, the inner section and put it there. Put them back together in reverse order, but also note, are there any, I'm going to call them funky, anomalous sections? There's like way too much straw here. There's like, it's way too wet here. It's way too dry. That would be a 4th pile, and you tend to put that anomalous stuff in the core where the decomposition is the strongest and the fastest, and it'll work itself out.